Okay, so I have made this speech emotion recognition project using the test dataset from Kaggle. Here is the dataset link. So first of all, we import the required libraries, that is NumPy, Pandas, Librosa for audio files, then scikit-learn, and then Matplotlib and C1. After that, we have to load the data, that is, we have to download it from Kaggle using these steps. After downloading this data, you have to unzip it. The unzipped data will be found here in your Google Colab or wherever you are doing this. Then we list all the directory paths from this file. It contains all the label data uh, inside it, these folders. Then we make a function for loading the data, that is the load data function, that returns the path and the labels. That is these are these folder names ending with fear, surprise, sad. These are the labels, and each of these folders are containing all the audio files. So this will return the path for this audio file and the corresponding label. So we store that in this. So here is the listing of all the labels in a set, and that is the unique labels, that is neutral, sad, angry, disgust, happy. After that, we make a data frame out of it. This is the sample of that data frame. Then we have performed a count for each of the uh, distinguished label, that is each of them are having 400 audio files. After that, we are performing data analysis for that. First of all, we are converting each of these categorical data into one hot encoded data, because the machine cannot understand this type of data. It has to be passed in some kind of numerical data. So we have to we are performing one hot encoding here. So these are the number of uh, rows available for each of those, that is sad and all that. After that, we have made two functions, the wave plot and spectrogram. So this wave plot function plots the wave function uh, wave diagram for that audio file. It looks something like this, and the spectrogram plots the spectrogram diagram for the audio file like this. So we are also adding the sound file from each of the different output levels, that is fear, surprise, sad. Let's play one. Okay, so this sound file has a wave plot like this, and the spectrogram looks like this. Similarly, we get it for sad. Yeah, it has a wave plot like this and a spectrogram like this. Uh, so we do that for all the seven of them. Okay, now comes the part of feature extraction. We have to extract the features from the audio files. So we use a thing called the male frequency septal coefficient. This is a feature extraction from the audio file. So we use Librosa library for that, and extract the MFCC from each of the audio files. We and then store that in XMFCC and all that, and then here we are expanding the dimension of X after storing the features in that. You will understand why we are doing this. First of all, we are also dividing the dataset into train and test sets. So we import our libraries used for training the used for making the model, that is the LSTM, dense, dropout, and sequential models. Uh, Now we are building our main model. So it is a sequential model that consists of LSTM, then a dense layer, then a dropout layer, then again a dense layer and a dropout layer, and at the last a dense layer of 7 output with the activation softmax, that is a classification layer. So these are the total number of parameters of this model. Then we fit this model. Okay, so I said one thing, that why we are expanding in this. This is done because sometimes LSTM architecture, it is made in such a way that it will not accept this. So we have to expand this so to add this extra dimension so that LSTM model accepts this data. Then after we create the model, we fit it. Here is the training information. Like at the last, you can see we trained it for 30 epochs. Then we plot the training and validation accuracy. Then the validation loss, training and validation loss. After that, we see how our model has predicted. So we predict our test data that we have split earlier. So the accuracy after doing that comes to be 98.57%. Then we have constructed our confusion matrix. You can understand it by this way, that the 7 levels are here: happy, sad, neutral, and all that, and also in the column happy, sad. So if it is happy and it predicts happy, then uh, number of such cases it shows 86. That is, it is doing good, means it has identified it correctly. And all these 2, 1 and all, these are incorrectly identified. Similarly for all the other levels. So the diagonals should be the maximum for a good model. For that we get our classification report. Uh, this is the precision, recall, and F1 score and support for all the features and all the levels, neutral, side, on that. After that, on basis of that uh, confusion matrix, we also have constructed our correlation heat map to get a better idea. The diagonal is deeply colored, so the model is working really good. So this is our project about speech emotion recognition. Thank you for watching.